There are several reasons why we might want to calculate the proportion of a normal distribution that is within a range of scores. Conveying information about this range, as with other explorations of data, can be facilitated with a graph. In this video, I'm going to construct such graphs using R statistical software. Unfortunately, R does not have functions for the kind of graphs that I think would best display proportions of the normal distribution. I envision a picture of the distribution that has a highlighted area corresponding to a score range. One of the beautiful aspects of R is that statisticians and students write functions for what they need, and then they share these functions with others. This makes R an extendable software package that grows every day. So, I asked myself, said I, why not create a function to draw the graph you envision and then share it with those who watch this video? So that's what I've done. Here's a script that begins with a function called source. All that the source function does is to load a second script. I'm loading a script that I called normaldist_areas.r. This script contains my graphical functions. By using the source function to load that script, those functions will be available within the script that you see here. A word of caution. For our script to work, we must make sure that the normaldist_areas script is in our working directory. The easiest way to make sure this is the case is to use a project and put the script in the project folder, just as we would with any script we want to use in our project. You can see that I've done that. When I run the source function, my new functions appear in the environment pane. Let's put them to work. Children's IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. What proportion of children are expected to have an IQ below 80? I'm going to call on the function that I wrote called norm.area.below. The parameters of this function are the cutoff score of 80, the mean of 100, and the standard deviation of 15. I'm going to run this. That's the picture I was hoping for. I have shaded in the area under the normal curve that is below 80. I've also calculated the area proportion and have displayed that at the top of the graph. The proportion of scores that are less than 80 is about 0.09. What proportion of children are expected to have an IQ above 110? This time I will use the function called norm.area.above. Let's run this. Again, I see the area under the normal curve that corresponds to scores above 110. I also am given the information that this area is 0.25 or about 25% of the entire distribution. What proportion of children are expected to have an IQ between 80 and 110? The function I need now is called norm.area.between. Note that this function has an extra parameter because I need to give both a lower and upper bound. In this case, the lower bound is 80, the upper bound is 110. As usual, I also need to supply the mean and standard deviation of this normal distribution. When I run this, I get a graph in which the area between 80 and 110 is highlighted. along with the information that this highlighted region is approximately 66% of the area under the normal curve. What say you? Pretty nice? If you want, you're welcome to look at the normal dist area script that contains these three functions. And you can even fiddle with those functions. For example, you could change the color of the shaded area from red to some other color, such as blue or green or papaya whip. Yes, R has a color called papaya whip. Do a web search on R colors to see many fascinating names for colors. If you do make changes to the functions, before you run those functions, you'll need to run the source function again to load these changed functions. Here's an important public service announcement. It would be easy to use the functions that I created and never learn how to calculate the proportion of area on your own. I'm not talking about drawing the graph. That's more complicated, and it's why I wrote these functions. I'm talking about calculating the proportion of area below or above a score, or between two scores. Knowing how to calculate these proportions is an important skill in statistics. Not learning this because you have these graphing functions would be akin to saying you don't need to learn 3 times 4 because you can always punch it in on a calculator. There are some skills that are important for our day-to-day living, and understanding the meaning of 3 times 4 without having a calculator handy is one of those. Similarly, in statistics, knowing how to calculate proportions of the distribution is an important skill. Enough said. I hope you find that these functions provide a nice way to picture specified areas under the normal curve.